Hey guys, this is Brajesh. Today we are going to talk about an open source machine learning framework that was created by Google. That's right, it's TensorFlow. So you can build a lot of machine learning models and deep learning models using TensorFlow. And as far as the programming language is concerned, TensorFlow uses Python as the front-end API to build the models. But the actual computations are performed by C++ in the backend. So how does a TensorFlow work? And why is it so popular? So TensorFlow allows us to create data flow graphs. And if you look at this, you can see how the data flows through the graph. So each node in the graph represents a mathematical operation. Now, if you look at this example, we have two inputs, x and y. So the first operation that we are performing is addition, and in parallel, there is a subtraction operation going on. And the results of both these outputs are stored in Z. So if you had watched my last video, I would have spoken about parallel computation in Python. And if you haven't watched it, do watch it to have a better idea. So TensorFlow also performs this similar kind of operation and it does it in parallel. So let's go to the implementation part. So I'll show you first how to install TensorFlow. And the command to install TensorFlow is pip install TensorFlow. And when you execute this, it will get installed. So once you have installed TensorFlow, the next thing is you have to import it. All right. So in TensorFlow, all the computations involve tensors. So first you should know what is a tensor. A tensor is an object that can be a scalar or vector. So all the values in a tensor should have identical data type, which means that it can have only one data type at a time. So if you look at this, I am first defining constant. So the basic idea of a constant is that once you declare it, its value can't be changed in the future. So I'm just defining a string. So I'm saying my first program using TensorFlow, and this is a constant that I'm defining. So usually in Python, when you first declare an object and if you display, it will show you the value. But here, this is a tensor, and what it shows is it is displaying the name of the tensor as const1 and the shape and the data type, which is a string. So basically, a tensor has three properties: a name, the shape, which tells you the number of dimensions, and the data type, which is a string in here. So if you check the type of this, it's a TensorFlow tensor. So to run the operations between the variables, you have to start a session. This is how you begin a session. And the way you run these operations is through the function called session.run. And you pass in the tensor, which is getting stored in output. And once you have performed the operations, you have to close the session. So now the result is getting stored in output, which I'm going to display here. And if you look at this, the string which I had defined is getting displayed here. So there's another way of creating a session. So you can define it using with, and the advantage of using this is it automatically closes the session. So I'm opening the session here and I'm running the tensor. So now if you display the output, right? So you don't have to close the session here. It automatically does it. So let's take an example of a numeric value. I'm initializing a constant with a value of 100 and I'm giving a name, say x, and the data type that I'm defining it is integer. So let me execute this, and if you see the name of the tensor that I have given it as x and the data type is integer. So if you check the rank of this, it's 0 because it's a scalar. So let's define another value. So I'm defining another constant with a value 200 and I'm naming it as y. It's again an integer. So now I'm going to perform few operations here. So with the same example that I showed you, so we first saw that we had two inputs x and y. We are doing an addition operation, a subtraction, and finally we are storing the result in z. So I'm going to do the same thing here using TensorFlow. So I have the x and y defined, and the first operation that I'm doing is addition here of value 1 and value 2, and I'm naming this as add, and I'm showing it in value 3. So secondly, I'm doing a subtraction operation. I'm naming it as sub, and the result is getting stored in val 5. So val 5 will give me the output, but apart from this, I'm also doing a conversion operation. So I'm converting integer variable to float 32, and the way you to do that is using cast operator. Similarly, you can also convert it using a to underscore float function. Now let me execute this. Yeah. So I'm running the outputs of all these things, val 1, val 5, val 16, and val 6 and val 7. So it will display the results of the addition operation and the float value, and I'm printing it. So if you see the result, it's 400, which was an integer, and then after conversion to float, it is displaying it as 400.0. Okay, so let's go to the next example. So now I'm defining a matrix, and I'm filling all the values inside the matrix with 5, and the shape that I'm passing it is 3 comma 4. So I'm going to define another matrix with constant values, and the shape of it is going to be 3 comma 4 as well. So you can also fill a matrix with the zeros in the defined range. So I'm creating a matrix with zeros in the shape of 2 comma 3. So let's see what operations can we do using the matrix. So I'm first doing an addition operation here for x comma y, and remember the shape should be same to perform addition, subtraction, or multiplication. And so the way you perform subtraction operation is this: you have a subtract function, and I'm going to multiply. So this multiply is element wise multiplication, and I'm doing a matrix multiplication. So to perform a matrix multiplication, I'm defining another tensor, the shape 4 comma 3, and I'm performing division here. So this again is element wise division, and it's just going to give you the dividend part. So there's another divide which is going to give you in decimals. So the result will be in decimals, and you can check the power. So I'm going to take the power of all the elements in y by 2, and you can perform a concatenation operation also. So I have mentioned axis equal to 0, which means that all the elements of y are going to be concatenated to x row wise, and axis equal to 1 means that I'm going to concatenate by columns. So you can also check if the elements of y are greater than 6. So the function to check if the elements in y are greater than a certain number is using the function greater underscore equal. So greater underscore equal means you can check whether it's greater than or equal to. And similarly, you have a greater function which checks if it's greater than 6, and less equal, which means that you can check whether the elements of y are less than or equal to 6, and less meaning you can check if it's just less than 6. And there's a function to check if all the values of all the elements of y are equal to 6. And the next operation here that I'm doing is reduce underscore all. So the first input that I'm passing is to check whether all the elements of y are greater than 1. So I'll explain it to you once you see the result. So you get the Boolean result as true if the element of y is greater than 1. So similarly, all the elements are compared whether it's greater than or equal to 1. And the final result is going to be either true or false, meaning it will give you just one result and it checks whether all the elements are true and it will give you a result of true, else it will be false. So I'm going to print the result of x and y, and I'm going to print the results of all the operations that I showed you here. So yeah, let's execute this. Okay, y is not defined. All right. So now if you look at the results, I'm displaying x and y. So this is how my matrix looks like. It's a 3,4 matrix. And remember, I had shown how to display the zeros. So I had initialized a matrix with just zeros and the shape of it was 2,3. So this is the result of it. So I'm displaying the dimensions of the tensor. Here it's a two-dimensional matrix. And that's why the results are getting displayed as 2, 2 for both x and y. And the way you check the dimensions is through the rank function. And if you look at the results of addition, subtraction, multiplication, element-wise division, and here this division gives you the results with all the decimals, the power, and we had checked the Boolean operation to compare whether all the elements of y are greater than or equal to 6. Likewise, all the results for greater than, less than or equal to, less than, and equal to. This is the concatenation by rows, the concatenation by columns, and the final result that I showed you for reduce underscore all function. So it gives us just one result after comparing whether it's greater than or equal to 1. So this is it with the first session of TensorFlow, where I've explained what a TensorFlow constant is. In the next session, we'll be dealing with the variables, the placeholders. So if you like this video, like and share this video. Thank you.